In today's lesson, we're multiplying binomials again, but today we're looking at some special cases. The first is squaring a binomial, so a plus b squared. Now a plus b squared is a plus b times a plus b. If we use our FOIL method, first, outside, inside, last, and look at multiplying the first terms and the last terms, we get a squared and b squared. Then if we do the inside and the outside, we have a times b and a times b. So we have two of the same thing. So we end up with a squared plus 2ab plus b squared. So we can use that to square a binomial. We're just going to square the first term, square the second term, and then multiply the terms together and go times 2 to get the middle term. So let's look at an example. X plus 7 squared. We're going to square the first term, so we get x squared. We're going to square the second term, so we're going to get 7 squared. And then we're going to multiply 7 times x and go times 2 to get the middle term. So we have x squared plus 14x plus 49. Okay, here's another example. 5x minus 3 squared. We're going to square the first term. 5x squared is 25x squared. Square the last term. 3 squared is 9. And then multiply the two terms together. Negative 3 times 5x is negative 15x. And then times 2. So we get 25x squared minus 30x plus 9. So whether the sign is positive or negative, the last term, because we're squaring the second term, is always positive. All right, here's one for you to try. 3x minus 4 squared. Pause the video, figure out what that is, and then resume. 3x squared is 9x squared. Negative 4 squared is 16. 3 times 4 is 12 times 2 is 24. So 9x squared minus 24x plus 16. Here's another one to try. 2x plus 5y squared. Pause the presentation, figure out the answer, and then resume. The answer is 4x squared plus 20xy plus 25y squared. 2x times 5y is 10xy times 2 is 20xy, our middle term. All right, we can use this to square something like 29 squared. Now, why would we use this instead of just taking a calculator and going 29 squared? Well, suppose there were some global pandemic and you were stuck at your house and trying to figure out things to do and challenge your mind so you don't lose all your math abilities in your brain, or you wanted to impress your parents. Well, here's something we can use. We can rethink 29 as 30 minus 1. So 29 squared is 30 minus 1 squared. And so now using our technique, 30 squared is 900. 30 times 1 times 2 is 60, and 1 squared is 1. So now we can do this pretty easily because the 30 squared is easy to square and 1 squared is easy to square. So now 900 minus 60 is the 840 plus 1 is 841. So we can square something pretty quickly without a calculator. I don't know, maybe your little brother or sister is using your calculator to do their math work. So you're just trying to show that you're an advanced student and square something. Okay, here's one for you to square without a calculator. Putting that into a binomial. Square that and come up with the answer. So pause the presentation, square that, and come up with the answer. We could think of 71 as 70 plus 1. And so 70 is easy to square and 1's easy to square. So our answer would be 4,900 plus 2 times 70 is 140 plus 1 squared. And so we end up with 5,041. All right, so there's a technique we can use to square some numbers, put them into manageable numbers. All right, another special case is when we have two terms that are the same in both binomials, but one binomial is a sum and the other is a difference. So in one we have plus, one we have minus. So a plus b times a minus b. This is real easy to multiply. When we do the first terms and the last terms, again, we get the a squared and the minus b squared. When we do the inside and the outside, we get ab and negative ab. Well, ab and negative ab cancel each other out. So what we're left with is a squared minus b squared. This is a special expression called the difference of squares. And later, when we're going backwards in factoring, we'll see that when we're asked to factor the difference of squares, that becomes something very easy. So the expression a plus b times a minus b multiplies to a squared minus b squared. We just square the first term, square the last term, stick a negative sign in the middle. So for instance, 5x plus 7 times 5x minus 7. We're going to square the first term, 5x. 5x squared is 25x squared. We're going to square the second term, 7. 7 squared is 49. And then we're going to put a minus sign in the middle. And there's our answer. Easy. Okay, here's one for you to try. 2x minus 4 times 2x plus 4. What's the answer? Because this is so easy, you should have come up with that very quickly. 4x squared minus 16. Here's another one. What's 3p plus 8q times 3p minus 8q? 9p squared minus 64q squared. Okay, a plus b times a minus b. Easy. Square the first term, square the second term, put a minus sign in the middle. Now, again, if we're looking for a way to use that to maybe quickly multiply some values, and we have something like 43 times 37, we can put it in this form of a plus b times a minus b. 43 is 40 plus 3. 37 is 40 minus 3. So we can rewrite this as 40 plus 3 times 40 minus 3. Now we have that a plus b times a minus b. So we just square the first term, square the second term, and put a minus in the middle. And 1600 minus 9 is 1591. All right, here's one for you to try. 56 times 44. Put it in that a plus b times a minus b and see if you can quickly calculate the answer without a calculator. 56 and 44 would be 50 plus 6 and 50 minus 6. And 50 is easy to square, 2500. 6 is easy to square, 36. So we end up with 2500 minus 36 is 2464. All right, next we're looking at applying this to a specific kind of problem. So here's the problem. A graphic designer is developing images for icons. The square pixelated image is placed inside a border that is 2 pixels wide on all sides. If the area of the border of the image is 176 square pixels, what's the area of the image? X is going to represent the length of the image. Okay, so that we can understand what this is saying. It's saying the border is 2 pixels wide. So the border is 2 pixels wide. That's 2 pixels, and this is 2 pixels. So altogether, then that becomes plus 4. The X plus 2 plus 2. Okay, so in order to find the area of the image, we have to find x. So we have the total area of the figure. We have the x plus 4 times x plus 4, or x plus 4 squared. We have the area of the image. The image was x units, and it's a square, so x by x is x squared. And then the problem told us the area of the border was 176. So if we take the total area and subtract the area of the image, we're left with the area of the border, 176. So now, x plus 4 squared, square the first term, square the last term, multiply the terms together and go times 2 to get the middle term. We get the x plus 4 squared is x squared plus 8x plus 16, and then we have minus the x squared equals the 176. So now x squared and minus x squared will cancel each other out, and then we can subtract 16 from both sides and then divide by 8, so we get x equals 20. So that's the length of the side of the square. The problem asks us for the area of the image. So the area of a square is the side squared, or 20 by 20 pixels, which is 400 square pixels. Okay, if we ask a new question, what is the area of the square image if the area of the border is 704 square pixels and the border is 4 pixels wide? So we've changed the area of the border and we've changed the width of the border. Figure out the answer. Okay, pause the presentation, figure out the answer, and then resume. Okay, you think you got the right answer? The right answer is 1600 square pixels. Since the border was 4 inches, 4 inches plus 4 inches makes a total of 8 inches. So the entire icon is x plus 8, and so that area is x plus 8 squared, and the image is still the x squared. And then it said that the area of the border is 704. And so x plus 8 squared is x squared plus 16x plus 64. The x squareds are going to cancel. We're going to subtract 64 from the 704 and then divide by 16. So there's our x equals 40. Okay, that's our lesson on special cases, which the word problem may have given you a little bit of a challenge, but the two special cases, a plus b squared and a plus b times a minus b, should be very easy when you're multiplying. So, time to do the classwork, or in your case, the online work. All right, good luck with it. I know you'll do great.